Hi, my name is Paul. I'm the founder and CEO of a software company called Octopus Deploy. One of the challenges that we've run into as the company has grown is how we share information that's going to be relevant to the work that everybody's doing without involving everyone in every single meeting. So the solution that we've come up with is a short meeting that we do once a week called the TLDR, Too Long Didn't Read, where people can share anything that they think is going to be relevant to most other people in the company. Now, for me, the TLDRs are the highlight of my week. I get to see things that are going on around the company, and they cover a wide variety of topics. It could be things like the design of new features that are coming down the pipeline. It could be support incidents where we're trying to share what we learned, and it could be anything development related. As an experiment, we're going to try recording these TLDRs and publishing them to YouTube and see what you think. So first up is Rob Perez. He's going to walk through some improvements we've made to browser caching and to reduce the overall number of requests that we make to the front end. After that will be Michael Noonan. He's going to walk us through the process that he followed using JetBrains .memory profiler to be able to diagnose some performance issues that we had around memory allocations. So stay tuned. I hope you enjoy.
All right, are we good to go?
Good.
Sorry.
Action.
All right. So I'm just going to demo some of the stuff I've been working on in terms of making the browser a little more performant, particularly around the dashboards. So we all know there's a bit of a performance issue with dashboards and project overviews. And part of that's a back-end problem, and part of that is just the way we sort of refresh and pull down all that data and process it on the front. So I've been playing around with some browser-side caching mechanisms for the front end, and I will share my screen because that might make more sense. Okay, so as you can see here on the project screen, basically every 4 seconds, I think it is, it hits the progression endpoint, and that pulls down all the information we need to render this overview. You can see here, in this case, it takes about 2 seconds to pull down. Of that, about 2 seconds is waiting, so that means that's processing on the server side. If we have a look at the server itself, you can see here every 4 seconds, I'm getting this massive big spike in the CPU, and that's from serving that I'm one user looking at one project. And granted, this isn't a huge VM, but you can kind of see what that's doing to the CPU there. So I've added in a browser caching that I'll go over a little bit more of the detail later, but just to kind of see the effect. So I've disabled it. So I've got a feature flag around it, so that way we can sort of turn it off if we need to, just as sort of an easy exit point if there's any problems. We might end up removing this in the future if we find that it kind of goes through smoothly. I've tested across a whole bunch of browsers and all looks fairly good, but let's turn that on. That will be enabled by default as well. So that's now going to be enabled. So you can see that that was taking about 2 seconds for a normal request, but now I'm starting to get 304s, not modified. And you can see immediately the size difference from 3.4K to 280 bytes. And it's going from about 2.5 seconds to about a third of a second. And if I can hover over, it's not going to show anything, but if we look at the actual server now, you can see now how quiet that's become. So what that's doing in the background on the server is it's actually just hitting the events table, and it's using the events table to signify whether or not anything has changed across the system. Again, I'll go over that in a little bit more detail in a second, but I'll just show another example of where that sort of really comes in handy. So we'll just disable that via the dev tools here so we can kind of see the before. Now we'll go in this case to the dashboard. I think that's the dashboard API. So you can see here in this case, we've got kind of a slightly different problem with this dashboard, with this query. That's the actual data that's coming down, while gzipped is actually 5.2 megs, 289 gzipped and compressed, but that's quite a lot of data. And as you can see in this case, the main time is spent in waiting for that content to come down across the wire. The processing on the server is not too bad, but again, every single hit, now you're taking 12 seconds, 13 seconds, it's pulling it all down. If I enable that browser-side caching again, so once that request finishes coming through, So again, we've got the 304 is not modified. That's taking, again, a third of a second. Tiny size. It's happening really quickly. And obviously the browser, as you can see, it's using that 5.2 meg that it requested from the previous calls. So that's all still there. And if you refresh this page, it's still going to give you the 304, but the browser will just use its cache version, and this will just come back. I'll give you a quick look at some of the back-end code, how we're doing that. So there's basically a really simple generic caching rule that I've added. If we go to and obviously my system's going a little bit slower because I've got Zoom running. But as you can see here, to actually use it on these endpoints, it's just a matter of slapping this rule on it. So it's kind of agnostic. It's endpoint agnostic in the sense it doesn't really matter what we decide we want to put this on. It's basically just a rule that runs before the request comes in. It checks to see basically if the browsing caching isn't enabled, just exit straight away. But it basically pulls off the E tag off the if non-match header that comes back from the browser. And then it appends that at the end on the request going out. So but it appends let me say that again. It'll pull off the if non-modified from the request, and then it generates an E tag, which is based off the latest event ID from the events table. And it includes also the user ID. So that way, by including the user ID, we make sure that if one user logs out of the browser and another user comes in and logs onto the exact same browser session, we don't get that contamination across users. Now that's a fairly sort of what I've called sort of just a naive rule. So if any event changes anywhere in the system, that cache will be invalidated and they'll get a new response back. I started toying with the idea of making it a bit more specific to the tying it to the project, but this kind of makes it simple and generic enough that we don't need to think too much about making sure that we're logging all the right events in the right places. This does mean, however, we need to make sure that we do log events that might impact the dashboard. And we've actually found one place where we're not currently logging an event that we'll need to add to. But yeah, so that kind of shows how simple it is if we've got an endpoint like the dashboards that we want to put this naive caching on, and we get a massive performance boost increase to the front end. And by hitting that, by giving just a not modified response, obviously we're not smashing the database server with those chunky queries. So it kind of helps everyone, the front end, the back end, everyone's happy. You might have noticed when I went to the configuration screen that these requests on that dashboard are still going. So that kind of brings me to another change that I've made in another endpoint. This will be a little bit quicker because it's a fairly simple change. So again, in this case, we've got the dashboard query going. This is obviously a very small instance, so the requests aren't huge to begin with. That's not so much what we're concerned about, but you can see it keeps going every 4 seconds. And that can get quite expensive if you've got, 100 users who've all got a tab open where they're pulling, it keeps hitting the dashboard. So with this new fix that I've got in this branch, as soon as you move to a different tab, we stop polling. So we're basically hooking into the page visibility API that most browsers expose now. It comes from IE10 plus, and in IE9, it basically just ignores this and it will keep polling as per usual. So we're kind of safe there. But as you can see, it stopped polling. I basically upped the polling to 5 minutes, so that way it's not overly stale if they leave it overnight and they come back. But as soon as you jump back into that tab, the polling will start back up again every 4 seconds. So as soon as you either change tabs or minimize the window, the browser considers that to be no longer visible. If, however, you bring another window on top of it, because technically the window is still kind of visible, that won't trigger that event. But again, it's kind of one of those enhancements there to make things a little bit better. It's not something that we necessarily need to be constantly kicking in at the right time, as long as Obviously, it either works or it doesn't work. So that again will reduce the amount of requests that are going back to the server. Obviously, in this case, on this branch, I don't have the 304 changes in place. But yeah, you combine the two, and I think that'll make the backend a lot more responsive. And in conjunction with some of the changes that are being made to the queries there, hopefully will reduce a lot of those performance problems we're seeing with the dashboards. So yeah, that's some of the work I've been doing. I'll probably merge those changes in the next day or two, once everyone's had a bit of a think about if there's anything else that is missing. Pavel's saying after Easter, once he's no longer on support. But yeah, so hopefully that makes a bit of a difference. Cool. I'll leave the questions till afterwards so we can keep moving.
Sure. Oh, that's amazing.
Hey.
All right, who is next?
I am next, I think. So I'll take over the screen share.
Should extend that to task force as well.
Yeah.
All right. This is supposed to be a rocket octopus, but it looks more like a rocket squid because I'm going to talk about performance as well, just really briefly. And this is just a very short demo, more an awareness talk, because we've been doing a little bit of performance work recently, and we've talked about that before. But one of the things that I haven't focused on, and this is more focused at developers, is just some of the tooling that we have that you may or may not be aware of that we've been using to do this analysis. So very similar to what Rob was doing, I've got an instance that I've set up here in my development environment, and there's no secrets here. It's just set up OctoFX, so it's very lightweight. And I've also just set up the NPM running and hosting this website using cores to the server. And finally, I've just gone back in time just a little bit because I've done some fixes in some of the 3.12 patches. So I've just moved master back to 3.12.1. And what I wanted to show you was a tool that we've all got access to. So ReSharper we use for some of the code efficiency when we're writing code. But one of the things you may not be aware of that we've got in here are the profiling tools. And so right inside of Visual Studio, we can kick off either a performance profile or a memory profile. And so what I wanted to show you today very briefly was memory profiling, because we had a support ticket come through. We've had two recently. One had an out of memory exception, and that was related to a very specific task that we run. And I'm just trying to remember, I think it was the deployment manifest cleaner. And so we've done work on that over time. And the newest one is somebody who is explaining that their Octopus server used up about 2 gigs of RAM, and they're on a 4 gig machine, and then everything becomes unresponsive and they have to restart the Octopus service. And so we're investigating that with that customer at the moment, but haven't got any really strong leads because we need better performance profiling. Now, interestingly, on OctoFX and on demo, we never really run out of memory. They do hundreds of deployments a day and everything's pretty stable. So there must be something different they're doing. But what I thought I'd show you is that you can just click on Run Startup Project Memory Profiling. And what this is going to do is run a quick build and then startup.memory. So what we're going to configure, and this all comes out of the box, it just grabs all these details from Visual Studio. And you just got to have your instance set up in there, which I did in Visual Studio already. And the last thing I'm going to do is start collecting allocation data. And what that means is that the profile is collecting stack traces when allocations are performed. So you know the source of those allocations. And hit run. Now .memory is going to fire up, and it's actually going to launch Octopus for me. So I've got my tentacles and my Octopus server stopped. So here we can see that's running in interactive mode, and then the profile is started up. Now in the background here, we should see, I might refresh that browser. Oh, there we go, it's kicked in. So now we're starting to make those polling requests. So if we quickly look at the dev tools here, quickly or slowly look at the dev tools. Maybe slowly. We should see those network requests flying through again once every 4 seconds. And over on the profiler side of things, we can see that we've got a bit of memory being allocated on startup, and a lot of it is sitting there in our early heaps. and it's in managed memory. An interesting thing that I noticed though is just out of the box on this version of Octopus, every one of these requests that comes through, we're allocating a fairly reasonable amount of memory. So we're already up to nearly 600 megabytes used in this particular profiling instance after running for, I guess, is that now a minute? And as you let this sit here, this clicks up. And so that's, you know, neither here nor there, because every one of those requests goes through and we have to allocate memory for the incoming buffers for the HTTP request, and then we allocate memory for the actual web API that we're using the service, and then we allocate some strings for doing database queries, et cetera, et cetera. And so that's all to be expected. But interestingly, if you just let this sit here for a while, we start moving into what this is saying is unmanaged memory now. It's the same kind of increments every time, around about 4 or 5 megabytes. But this is just an empty instance doing no productive work. So now if I click get a snapshot, what this is going to do is pause the process, do a garbage collect, and then have a think about where all of the different objects in memory are and write those down for us. And so now once this could take a little while, but this is like a freeze the world garbage collection. And once this goes through, we should see that all of this managed memory gets cleaned up. So it does its mark and it actually sweeps something. Now out of the box, Octopus works pretty well this way. You'll see here that we end up going back down to around about the same level that we were at quiescently when Octopus first started up. And that's around about 450 megabytes. And so now you can see these requests starting to come through again, and up we climb. So again, if we click get snapshot, what we do is get 2 snapshots, and you can look at what objects are retained. And the interesting thing about that is really when you're looking for memory leaks, so memory that is not recovered when a garbage collection occurs. And so here we can see a comparison between the two. We can see that 1.3 megs was recovered, and we allocated 65K on new objects. So now I might just kill that process just so I can get some perf back. And I'm going to compare, oops, sorry, click the wrong button. I want to go back and compare those 2 snapshots together. And it'll give me a bit of an analysis. I'm not going to drive into this, but what it's telling me is that there was 127 allocations that survived, and there was about 9 megabytes that survived through that. And we cleaned up about 1.3 meg. And so you can go through and do an analysis in here to figure out where a memory leak might be. Now, in this case, I'm not interested in a memory leak because it seems like that memory is coming back down again. But one of the things that actually impacts performance or throughput in an application is what this tool calls memory traffic. But it's to do with the amount of allocations you do, because every allocation takes time to allocate that memory, and then it also impacts garbage collection. So the more memory you're allocating for non-productive work, like just serving these web requests, we're actually incurring a cost to the overall service. So I think the thing that really stood out to me was it was just surprising that Octopus just kind of continually grows in memory usage. And so in this case here, the most expensive or the most allocated bytes in around about that, how long? That was about 10 or 15 seconds worth of work. We allocated about 2 megs, which equals about 50,000 objects. And so if you look, if you click on here, then we can dive down and say, why are all those byte arrays allocated? And it turns out a lot of them were allocated because of this SHA-1 crypto service provider. And so then we can further drill in and find our way down to where that is actually used. So I've driven down far enough here, and I can see that it's to do with master key encryption, and it's when we derive that from a password, and this is to do with building the master key encryption. And if I look at event store constructor, what's actually happening is we're saying we've actually allocated a brand new event store 48,000 times just doing non-productive work. And so this is a fix that we've done recently and shipped in Octopus 3.12.3 or 4 to reduce this. And event store is now a singleton, but it also uses a more efficient way of generating a hash. And really what that is writing audit logs to the event table. So this memory traffic does incur a cost. And so there's also other things we're doing around compression, gzip. So that kind of work there is per request, and there's not much we can do about that, but certainly the event store we could fix. And so now that that's done, the next thing will show up if we dig into it. So the reason I wanted to show this to you is just that so that you're aware that these tools are at your disposal as a developer. And if you're writing something that is just making a spelling mistake, fixing a spelling mistake, there's no real point in doing this. But some of the work we've done recently have been fairly major renovations on parts of code, and it probably makes sense just to do a before and after snapshot on these things and just sort of see what you think. Does it allocate a lot more memory than it used to? Yeah, is it performing as well as it used to? And some of that might just be run the previous version of Octopus deploy and do a deployment, upgrade, do another deployment. Does it run much slower? And as long as we're continually getting faster, I think our customers are going to be happy. So that was all I wanted to show. Was just a really quick lap around performance tools that are in your disposal. And finally, just on closing, we've written a few little documents, mainly on how-tos. Recently, I just sort of point out, one of them is about how to record problems in your web browser. So if you're experiencing something that goes wrong using the web browser with Octopus, we found a cool tool called FiddlerCat. And that's just a really easy way to record HTTP traffic. So there's been a few bugs recently. I know Pavel had one, which was like a timing thing. And that would have been, I think, possibly easy to fix in this case if we had HTTP traffic along with a recording of the screen. So that's all there in a fairly easy set of steps for our users to record things. There's some information here on getting our customers to record performance traces. I prefer the idea that we would catch these early, and we're doing work across the board to make that easier. But in certain cases, things just happen that we're not able to reproduce locally, and getting a performance trace from our customers has proven really helpful. And finally, about recording memory snapshots, and the customer that's having the reported memory leak is doing this at the moment, and we'll be collecting this information from them. And so it's got all the information there about doing pretty much the same thing that I just showed you in Visual Studio, but as an end customer. So that's it from me.
It didn't happen, Mike, until you forced it. So it shows that if there's enough memory, the usage will continue to grow. So the task manager isn't a good gauge of actual usage. Because once the memory pressure kicks in, it'll kind of kick it down. And SQL works the same way. So
yeah, exactly. Yeah, that usage is sort of, it is being used, it is incurring a cost, but it's not a leak, and it's not a big problem if you've only got one Octopus server. Hey, you got RAM there, let's use it. But I think the thing that does make this interesting is if we look at hosting a lot of Octopus servers on the same machine, if they're continually growing in RAM, they're going to be contending with each other for system resources more than they probably should.
yeah. And they're going to run more garbage collections than they need to.
Yeah, one thing that we did notice while trying this out and trying to make the memory leak occur without running a screen share at the same time, some of the garbage collections, the freeze the world garbage collections, were taking upwards of 40 seconds once we got up to the cap of memory. And so it was becoming a really expensive operation to do, and everything just freezes. And so some of our customers that are reporting Octopus goes unresponsive may be actually running into these issues as they hit memory pressure.
Quick question about the tools. Do they come as a command line tools so we could run them as part of our CI? Because I fully agree with that before and after. It just doing it manually, obviously, it takes time. So I'm wondering if...
Yeah, that's right. Yeah. So .memory definitely has a way to run from the command line, and they specifically talk about how to integrate it with your CI pipeline. And so you can do that and then do some analysis on it after the fact. I'm not sure about .trace though, but one of the help pages we wrote actually uses the command line interface tools, because it's just so convenient to say, give me a snapshot of your running memory space on your running Octopus server, and that's just one little command line that you add the PID to. So it definitely does.
Cool.